Like compound generators, we have compound motors in which the windings for the magnet is electromagnet is are both in the shunt and series to the armature. As you can see, series winding, they are thick wires, very few turns. Shunt winding, thin wires, many turns. Now, when you don't have any load and it is running freely, then of course we know that the armature current is very small, and when the armature current is very small, a very small current is going to flow through the series winding, and that is going to produce a very small flux, right? So we can neglect that. So without any load, it basically operates as exactly like a shunt motor. The main field is going to be produced by the shunt field. As you put the load and more current starts flowing to the armature to produce more torque to compensate for the load, then this is going to start increasing the flux. And now again, there are two types of motors. You have cumulative compound motor and differential compound motor. Differential compound motor basically subtract the two flux fields, and cumulative compound motor add the two flux field. So yeah, you have cumulative and you have differential. So what's going to happen when the field current is going to increase, that is the armature current is going to increase. If your motor is a cumulative motor and speed is inversely proportional to the flux per pole, if both the flux are going to add together, you have a higher flux. Higher flux means the speed of rotation is going to go down, right? Speed of rotation is going to go down. And if motor is differential, then they will subtract the flux will be subtracted from one another, and you have lesser flux and the speed of the motor is going to go up. So generally, of course, cumulative compound motors are used and differential motors, they are not used, because we don't want again motor to speed up as you are putting load on the motor. Otherwise again it can break. So cumulative compound motor do find practical application, but differential compound motor really do not find practical application. And let's look at, we discussed 4 different types of motor, and if you have 2 different types under compound, so 5 different types of motor. So this is the torque and speed relationship between different motors. You have series motor, compound motor, differential compound. Just compound means cumulative compound, differential compound, shunt. And as you can see, shunt torque and speed relationship is pretty straight, like it's not changing that much, the slope is not that high. Series, as you can see, high speed, low torque, and then when you have low speed, you have high torque. Differential compound motor, as your torque is increasing, that is, you're putting load, your current is going down, your speed is increasing, which it should not be. When you put the load, your speed should go down. When you need more torque, the speed should be smaller, not higher. And cumulative compound motors, again, you have less speed at higher torque, which usually it should be. Shunt motor has a very nice characteristic. As you can see, it has a speed and torque almost directly proportional to each other. At all speed, you have even torque available basically.